Hello friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio visual quality everything is clear so that we can start with the session. Till you are going to report me this, let me just brief you what is the ideal duration and what is the objective or agenda of the session. Friends, the ideal duration of the session is going to be approximately 1 hour, and the agenda of the session is that today we are going to discuss the second lecture. In the second lecture today we are going to discuss some of the important questions and concepts related to your subject power system as far as two upcoming exams are concerned, that is BARC and HAL 2022 examinations. So all the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether audio visual quality everything is clear so that we can start with the session. All the candidates who are joining me live, do not forget to like, share and subscribe the session. Like the session and share it with your friends and colleagues, and do not forget to subscribe to BYJU'S Exam Prep English YouTube channel so that you get all the important notifications of important sessions in time. Let us start with the session. Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience, completed MTech from BYJU in 2010. I have written a couple of books and my areas of expertise are electrical machines, power system, electromagnetic field theory, material science and engineering ethics. Before we start with the session, a very important information for all the candidates who have a little bit of confusion whether you should prepare for Engineering Services 2023 or GATE 2023 examination. Your favorite Ankit sir is going to bring a session, what should you choose, and the schedule of the session is going to be, this session is going to be on 10th of March, that is tomorrow, and I think it is 11 PM in the night. Just confirm the schedule on the same channel. The session link is available. Yes, good evening Shubhajit, how are you? Welcome to the session. Another important session, actually it is not a session, it is going to be a workshop which is going to be conducted by your favorite and my favorite Abhinav Negi sir, and this workshop is going to be conducted on 13th of March 12:30 PM. So this workshop is not going to be available on the YouTube channel. To attend this workshop, in this workshop Abhinav sir is going to tell you what is going to be your strategy to conquer GATE 2023, and believe me, this session is going to be extremely important for all the candidates who are seriously preparing for GATE 2023 examination. But in order to attend this session, you have to go to the BYJU'S Exam Prep that is available in the Google Play Store, download this app, and then only you have to do the registration, and then only you can join this session. Let us start with the first question for today. This question belongs to the reactive power compensation, voltage and power factor control. If you see the question, it says a three-phase induction motor is operating at 400 volts and 50 hertz. The rating of the induction motor is given, the complex or the apparent power is given, and its operating power factor is also given, 0.6 lagging. The question is saying, find the capacitance per phase of a delta connected shunt capacitor bank for improving the system power factor to 0.8 lagging. Now let us try to understand with the help of the diagram. In this diagram you can see there is a three-phase induction motor. If no compensation is provided, capacitor compensation is provided, then the rating of the machine is given, that is 4.5 kVA power it is taking at 0.6 power factor lagging. But the question says it wants to improve the power factor. Now please try to understand. Whenever you get a question with respect to the improvement in the power factor, please try to understand you can never improve the power factor of the load. Because once you design the load, you cannot change its power factor. Are you able to follow this? Because load is going to be a black box. What is inside you don't know. You can't change that. So the only thing you can do with the help of the compensation is you can improve the system power factor, and that is what clearly mentioned in the question, to improve the system power factor. So he wants to improve the system power factor from 0.6 to 0.8 lagging. Now let us try to understand how you are going to proceed in this question. The first thing you should understand is you can use the direct formula. The reactive power supplied by the shunt capacitor bank, directly you can write, and that is the formula. If you are not aware with this formula, then I can tell you some concept also, that is tan phi 1 minus tan phi 2. If you are not comfortable with this formula, you can just tell me in the comment section. I will just explain you a little bit that how this formula is coming, and then you will be able to understand what I am doing here. Now please understand, what is this P load? This P load is nothing but the real power taken by the induction motor. Can you write this real power taken by the induction motor directly? Yes, because you know what is the complex power. So directly you can write the complex power and multiply the power factor of the induction motor. Yes or no? So this is going to be 4.5 kVA. So this is going to be 4.5 kVA. So 10 to the power 3. What is the power factor? The power factor is given as 0.6 lagging. So this is going to be 0.6 lagging. Just try to find out what is the real power taken by the induction motor. Is it clear for everybody? Now the moment you get the reactive power, lagging reactive power, what is this? This is the lagging reactive power. Lagging reactive power supplied by the shunt capacitor bank to the system. What is the system? The system is the supply and the three-phase induction motor. Now this reactive power you can also write in another way. What is that? You can write this reactive power, because it is three-phase, so you can write it as 3 times V phase square upon XC. What is XC? XC is the per phase capacitive reactance of the shunt capacitor bank. Now in the question actually he is asking you the capacitance per phase of the delta connected load, delta connected compensation. That is why we are trying to find the capacitance per phase. Now this XC you can write as 1 upon 2 pi f into capacitance per phase. Just put this value here. So it is going to be 3 times V phase square, and this is going to be 2 pi f capacitance per phase. Now from this equation, if this value is known, because P load you have just solved. What is this tan phi 1 and tan phi 2? Very easily you can find, because the initial power factor is given. So initial power factor is given. So phi 1 is going to be cos inverse 0.6, and what is going to be phi 2? It is going to be cos inverse 0.8. So phi 1, phi 2 values you can find. Put it here. P load you can solve it from here and put it here. Yes, Shubhajit is saying he is getting 2.7 kilowatt. Everybody just confirm 2.7 kilowatts. Just confirm this. So you will be able to find the reactive power supplied by the shunt capacitor bank. So you know all these values. This value is known. Frequency is known. What is the per phase voltage? Can you tell me? Now please understand, this is a delta connected shunt capacitor bank. For the delta connection, you know the phase voltage and the line to line voltage is going to be same. What is the voltage given here? 400 volt. So the per phase voltage is simply going to be the 400 volts. So you know what is the per phase voltage. You know what is the reactive power supplied by the shunt capacitor bank. You know the frequency. So very easily you can calculate the capacitance per phase. As per my memory, it must be coming as 10.44 microfarad. Is it clear for everybody? Shubhajit is saying Q shunt is 1.578. I'm just writing it here. So you can just confirm these values given by Shubhajit. It is 1.5748. at least one candidate is doing the numericals. That is the best thing, because unless you practice it on your own with your own hands, it's not going to happen in the real examination. So it's a very good habit, Shubhajit. All my best wishes with you. See the next question. The next question also belongs to the reactive power compensation. Now let us try to understand what the question is asking. The question is saying there is a 3-phase induction motor of 500 horsepower with 90% efficiency and operating at 0.8 power factor lagging. Now before I proceed, let me just give you some idea why these three informations are given. Number one, whenever for any motor, whether it is induction motor or any other motor, whenever the power is output power is given, you please try to understand, or power is given in terms of the mechanical output, that is the 500 horsepower. Horsepower means he is talking about the power in the mechanical system. So that power is definitely going to be the output power. Yes or no? Now you are having the output power. Why he is giving you efficiency in a compensation question? Because by using the output power and the efficiency value, that is 90%, you can very easily find what is the input power or the power taken by the induction motor from the supply. Now, in order to have a clear-cut distinction between the real and reactive power, he is also giving you the power factor. So now you understand, wherever these three informations are given, you will directly understand what the question is trying to tell you. Second statement. He is saying there is a loaded 120 kilowatt synchronous motor which is connected so that the overall power factor becomes unity. Again, I am trying to stop you here and understand the concept. He is not improving the power factor of the induction motor, he is improving the power factor of the system to unity. And let us try to understand what is the meaning of unity power factor. I will tell you. Now he is saying find the power factor of the synchronous motor. Now if you are comfortable with the concept, then you will directly understand that actually he is talking about the synchronous phase modifier. Now what is synchronous phase modifier? Let me tell you. Yes, good evening Wagmi. Now in general, for basic compensation or dynamic compensation, you can understand, for dynamic compensation, you can talk about two important devices. Number one is synchronous condenser and the second one is synchronous phase modifier. Synchronous phase modifier. Now synchronous condenser, how you are defining it, is an overexcited synchronous motor at no load. This is the most simple definition of these two compensation devices. What is synchronous phase modifier? Synchronous phase modifier is an overexcited synchronous motor having some practical load, practical or real load at its shaft. And this is the reason why we call synchronous phase modifier as the most practical compensation device. Most practical compensation device. Because if you observe here in this question, this synchronous phase modifier, that is the overexcited synchronous motor, it is taking the real power from the supply. That is why we are saying some practical, some real load is connected to its shaft. So in order to cater to that load, it requires to take some real power from the supply, and at the same time it is supplying some reactive power for the improvement in the power factor to the system. Everybody is okay with this? Mr. Sarat Andukuri is saying, sir, are questions from critical clearing angle in stability important for BARC? Yes, you can get a question. Okay, directly remember the critical clearing angle formula. Okay, and in some of the previous sessions I have discussed some questions on that. You can watch that during the time of GATE examination and for engineering services examination also I have discussed that. Okay, just maybe 15-20 days or 1 month back you can watch those sessions and it is going to be useful for you. Now please try to understand what is the meaning of unity power factor. What is the meaning of unity power factor? Suppose this is your load. Okay, it may be some load. Induction, actually it is induction motor, it may be any other load also, and this is your synchronous phase modifier. What this synchronous phase modifier is doing, it is taking some real power from the supply and at the same time it is giving some reactive power to the supply. This is going to be P load plus JQ load, the real and reactive power taken by this load from the supply. Now when you say unity power factor, what is the meaning of unity power factor? Unity power factor means phi is going to be 0. What is the meaning of phi 0? The meaning of phi 0 is if you draw the power triangle. This is P, this is Q, this is S, and this is the power factor angle. Now which power factor he is talking about? He is talking about the system power factor. When you are talking about system power factor, you are interested in the real and reactive power coming or reaching at the load end. If you want to make this power factor unity or the phase angle 0, it means you should reduce this Q value to 0. Then only this angle is going to be approximately 0 or exactly 0. Now making this unity power factor means the reactive power coming from the supply end is going to be 0. The reactive power which is coming from the supply end is going to be 0. What does it mean? It means whatever is the reactive power requirement of the load, suppose it is an induction motor, this requirement of the reactive power is being compensated by the synchronous phase modifier. Is it clear, everybody? Just tell me in the comment section. Are you able to follow this? It means if I have to write the reactive power supplied by the synchronous phase modifier or simply the synchronous motor, it is simply going to be equal to the reactive power taken by the induction motor. How you can write the reactive power of the induction motor? Just draw the power triangle. This is real power for the induction motor. This is reactive power for the induction motor. This is the complex power for the induction motor, and this is the phase angle or the power factor angle for the induction motor. So directly you can see, you can write Q induction motor as P induction motor tan phi induction motor. Yes or no? Tell me in the comment section. Now this value is directly mentioned in the problem. What is phi m? Operating power factor he is giving you 0.8 power factor lagging. So phi induction motor directly you can write as cos inverse 0.8. What is P induction motor? P induction motor is actually the input real power taken by the motor, induction motor, from the supply. Are you getting this? Tell me in the comment section. This P induction motor is actually the real power taken by the induction motor from the supply. Now you don't know what is that power, but he is giving you the output power, that is in mechanical terms, and the efficiency. So how you can write the efficiency? Efficiency of the induction motor you can write as output power divided by input power. What you want? Input power. So how you can write input power? Output power. What is output power? 500 multiplied by 746, because 1 horsepower is equal to 746 watts approximately, divided by efficiency of the induction motor, that is given as 0.9. So this value you can find it. What is the input power, input real power? Yes, good evening Suman, how are you? Welcome to the session. Now this input power, you can put it from here, and phi m is also known to you, so you can find what is going to be the reactive power supplied by the synchronous phase modifier or the synchronous motor to the system, so that the overall system power factor becomes unity. But he is not asking you this value, he is asking you the power factor at which synchronous motor or synchronous phase modifier is operating. For that purpose, you can draw the power triangle for the synchronous phase modifier. This is going to be PSPM, it is QSPM, this is going to be phi SPM, and this is going to be under root PSPM plus QSPM square. What is going to be the power factor? Power factor you can write as PSPM divided by under root PSPM square plus QSPM square. Now this value already you have given in the question. What is the real power taken by the, yes, Shivajit, he is saying it is 41 point, okay, it is 414.44, okay. P induction motor, he is saying, he is giving you the value, other candidates please confirm, 414.44 kilowatts, that is for induction motor. Now this value, the real power taken by the synchronous phase modifier, is already mentioned in the question. If you see, it is already mentioned in the question. He is saying you a loaded 120 kilowatt synchronous motor. So P value is already given, yes or no? P value is already given. So can you write this P value? This P value is already given, 120 kilowatt, and QSPM you have just found. So you can find what is the operating power factor for the synchronous phase modifier. Is it clear, everybody? Just tell me in the comment section. Is it clear, everybody? Tell me in the comment section. Yes. Let us go to the next question. See, the next question belongs to the economic load dispatch. I hope you are comfortable with this topic, economic load dispatch, because 1 or 2 questions, 3 questions you may get from this area also in the BARC examination. Okay. Now he is saying the incremental cost for the 2 generating units are given. The minimum and the maximum generation is also given, and he is asking what is the PD max with economic load dispatch. Now please try to understand what is the meaning of this PD max. Yes, Shubhajit, perfectly correct. But one thing you should understand, Shubhajit is saying the answer is 0.36, that it should be 0.36 leading, because it is overexcited now. Because it is overexcited synchronous motor, so this should be 0.36 leading. Okay, the options are quite matching, so you have to take care of that. Okay, any question I have missed? I think just let us do this question first, then we will go back to the previous question. That question belongs to the overhead line insulator. First we will do the economic load dispatch, then we will talk about that. Now please try to understand what is the meaning of PD max. It is simply the maximum power which can be delivered to the load without any condition. If there is no condition mentioned, economic load dispatch or any other condition is not mentioned, and if I ask you, by using these 2 generating units, what is the maximum power you can deliver to the load? So what you will do, you will go to the minimum and maximum generation limits, and you will say, sir, the maximum generation limit for both the units is 125. So we will use P1 max plus P2 max, and that will be the maximum power which can be supplied, that is 125 plus 125, and this is going to be 250 megawatts. 250 megawatts. Now this is, my friend, without any condition, without economic load dispatch condition. But in the question, he is not asking you this much easy question. He is asking you the condition for economic load dispatch, what is going to be PD max. Now please try to understand. With economic load dispatch, if he is asking you PD max, then you have to understand one thing. What is this condition? What is this economic load dispatch? Can you tell me? Economic load dispatch simply tells you that the incremental cost for all the generators must be same or equal. Yes or no? You remember that? That is the coordination equation. What is economic load dispatch? It simply says the incremental cost is same and that is equal to lambda. What is lambda? Lambda is the Lagrangian multiplier, and Lagrangian multiplier simply tells you that by increasing 1 unit of power generation on any generator, what is the cost involved? What is the cost involved? Rupees per megawatt hour. Now, for this condition, incremental cost to be same, please try to understand if the situation is something like this. This is the power and this is the incremental cost. If you see the equations for incremental cost, very easily you can understand these equations are like your straight line equations. Y is equal to mx plus c. If you put this incremental cost at the y-axis, it looks like mx plus c. So definitely these two straight line equations are going to be something like this. I am just making it randomly. I don't know what is generator 1, what is generator 2. I am not going in the detail. I am just telling you the concept. Now I had to ensure the maximum power to be supplied to the load. So where I will start? I will start from this, because this gives me what? The maximum power supplied by this generating unit. But the problem is this operating point is not possible for the economic load dispatch, because for this power, this must be the incremental cost, and this incremental cost is not available for this generator. It means I have to reduce this point. Up to which point? I have to reduce this point up to at least this point, because this is the point which will give me a common incremental cost, and suppose this is going to be P1 and this is going to be P2. Now you just add this P1 and P2 and you will be getting the maximum power which can be supplied by using the economic load dispatch condition. So what is the concept here? I am telling you the concept. What is the procedure? The procedure is, you find the incremental cost for the first generator when it is supplying the maximum power. Are you getting this? You find the incremental cost for the first generator when it is supplying the maximum power. So you find it for the P1 max condition. Similarly, you find the incremental cost for the second generator and for maximum power delivered by the second generator. Now from this diagram, you can very easily understand that when you are talking about the PD max, maximum power to be supplied to the load, you have to go for the minimum of these two incremental costs, because that will be available for both the generators. So when he is asking about PD max, you go for the minimum value of the incremental cost. So what is the incremental cost you are finally going to decide? That is the minimum value of the incremental cost for these two generators, like this. Now this is going to be my final incremental cost for both the generators. Is it clear for everybody? Just tell me in the comment section. Now for this incremental cost, I will find what is the P1 and P2. So now you will find what is going to be P1 for incremental cost, this one, and what is going to be P2 for incremental cost, this one. And now you can say PD max with economic load dispatch as simply as P1 plus P2. This is the concept involved. Is it clear for everybody? Just tell me in the comment section. Only one candidate is able to follow this, and rest all candidates, they are just listening it like a story, but that is not going to help you a lot, my friend. Either you participate fully or you don't participate. That is the best thing. Is it clear? Now let us see how easy this question is going to be after this discussion. What is the first thing I am going to do? I am going to find IC1 for what? P1 max. Can you tell me what is this value? What is going to be IC1? This is IC1, incremental cost, yes or no? What is P1? P1 is P1 max. What is P1 max? 125. Just put 125 here. So it is going to be what? 0.1, 125 plus, and this is going to be 20. So what is the value? It is going to be 12.5 plus 20. So it is 32.5. It is going to be 32.5. 32.5. What is the incremental cost for the second generator when it is P2 max? This also you can tell me. Just put P2 is equal to 125. So it is going to be 0.12, 125 plus, this is going to be 16. If you solve this, I think you must be getting as 31. Just confirm this value. Yes, Shubhajit, you are right. Just confirm this value. So this is going to be 31. Now what is the rule? The rule is when he is talking about PD max, you go for the incremental cost, which is the minimum of these two, 32.5 and 31. So what is going to be the final incremental cost? That is going to be 31. Now when incremental cost is 31, you don't need to find the constant power for second generator, because already you have just put 125 and you had got 31. It means the final value which you are going to use, P2 is going to be 125 megawatt. But you have to find what is the final value for P1. So how you can find it? If this value you are putting at as 31, what is going to be P1? It is going to be 31 minus 20 divided by 0.1. So this is going to be, I think, 11, 0.1, and this is going to be 110 megawatt. So just add P1 and P2 and you will be getting your answer. Is it clear, everybody? Just tell me in the comment section. Are you able to follow this? You must be getting 235 as the final answer. You must be getting 235 as the final answer. You must be getting it as 235 megawatts. Yes or no? Yes, Tejasvi. It is great if you are able to follow. See the, yes, this question. This question belongs to the overhead line insulators, another important area for power system. What he is saying, there are 4 identical insulator discs which are connected in the form of a suspension type string insulator. The ratio of shunt and mutual capacitance is 0.2. What is shunt capacitance? I hope you are able to understand it. If there are 4 insulator discs, then the mutual capacitances will be 4 in numbers, and the shunt or the pin to earth capacitances are going to be 1 less than that. You must be aware with this concept. If not, then you must read it. This is C dash, C dash, C dash. This is C, which he is calling as mutual capacitance. Actually, capacitance, there is nothing about mutual. We talk about mutual inductance, but simply because of the simple reason, because this capacitance is the capacitance in between 2 insulator discs. That is why he is using the term mutual. Some of the books are also using mutual, but that is not correct, because in capacitance we don't have anything like mutual capacitance, but it is okay. Some books you will be finding they are writing self capacitance also. Are you getting this? So this ratio he is giving you, shunt to mutual capacitance, that is C dash upon C. This he is giving you as 0.2. This is the value he is giving you. He is saying the total string voltage is 40 kilovolts and then the string voltage is, string efficiency will be, he is asking you the string efficiency, and he is saying if the static shielding is connected, static shielding is there with the bottom two units. Now please try to understand what is the meaning of static shielding. A separate shielding wire is taken here and it is connected in such a way that this current is actually compensated. Are you able to follow this? Suppose here it is I4, here it is I3, here it is I2, here it is I1, then here it is I1 dash, here it is I2 dash, here it is I3 dash. So this static shielding or the guard wire, what it does, it simply compensates this charging current I2 dash and I3 dash here. So by connecting this shielding wire, I3 dash will be compensated from here and I2 dash will be compensated from here. Now what is the advantage of, yes, good evening Shubha. What is the advantage of using this shielding wire and compensating this charging current? Now please try to understand. I will just give you one example and it is going to be 100% clear in your mind. Let me take one example. Suppose this is the situation. 4 insulator disc. This is pin to earth or shunt capacitance or a stray capacitance. Now if you see what is happening, the current here is I4, here it is I3, here it is I2, here it is I1, and this charging current is I1 dash, I2 dash, I3 dash. Now please try to understand what is happening here. Because of the presence of this I1 dash, I2 dash and I3 dash, the current in different segments of this insulator string is different. Even though these capacitances are same, when the capacitances are same, their capacitive reactance will be same. Now only because the current in different segments are different, the voltage across different insulator units or discs are going to be different. So what is happening here, you can very easily understand. I4 is going to be the maximum current, some current gone here I3 dash, so I3 is less than I4. Some current gone here, so I2 is less than I3. Some current gone here, so I1 is less than I2. So what is happening? The voltage across various units are going to be related like that. You can very easily write, just listen here, you will understand. I4 is greater than I3 is greater than I2 is greater than I1. XC1 is equal to XC2 is equal to XC3 is equal to XC4. Yes or no? Because all the capacitances we have taken as same. Yes, Shubhajit, you are perfectly correct. Listen. But let us understand. So what you are going to do? You are going to do is V4 is greater than V2 is greater than V2 is greater than V1. Now because you are compensating this charging current, now when the charging current is not there, it means the current in this segment I4, I3 and I2, they are going to be same. When the current is same, then the voltage across these three units is also going to be same. So you can say the voltage across second unit, third unit and fourth unit, this is going to be same and V1 is going to be different. So do you have any relation between V2 and V1? Yes. This ratio we are calling as K. If you remember the theory part, V2 you can directly write as V1 1 plus K. Now this you can write as 1 plus 0.2. So this is going to be 1.2 V1. If you know what is V2, very easily you can write V3 and V4 because they are same as V2. So they are also going to become as 1.2 V1. So if you have all the voltages now related, very easily you can find the string efficiency. What is the expression for string efficiency? The expression for string efficiency is voltage across the string divided by number of units multiplied by voltage across the unit nearest to the conductor, that is V4. Yes or no? So this is going to be V1 plus V2 plus V3 plus V4, 4 units, and the voltage across the unit nearest to the conductor is going to be V4. But you know, this is going to be V1 plus V2, V3, V4, they are going to be 1.2 times V1 divided by, this is going to be 4 into V1 into 1.2, multiply it by 100 and you will get the string efficiency directly. Everybody just tell me in the comment section, are you able to follow this? This was a very interesting question. You must be getting some simple questions, but if you are able to handle this question, then easy question very obviously you can handle. Is it clear for everybody? Just tell me in the comment section. Are you able to follow this? And I'm not able to see any enthusiasm in the comment section. I think I'm doubtful whether you are enjoying the class or not. It should not be 95.83. It must be getting, I'm not sure. Just check it, what is the answer you are getting. I'm not sure what is the answer you are getting. Just check this value. I'm leaving this to you. Just solve this calculation. Okay. Let us see the next question. Now this question belongs to the differential protection. Yes, Shivajit, I know you are enjoying. This question belongs to the differential protection. If you are not aware, let me tell you what is differential protection. Differential protection is a scheme which takes the two samples of the same physical quantities from two different locations, just compare it. If there is a difference, it will send a trip signal to the circuit breaker, or you can say some current is going to pass through the relay operating coil. The relay is operating, relay is giving a trip signal to the circuit breaker is operating, and the circuit is disconnected or open circuited. This is what is happening. So the basic idea about differential protection is that the difference of the two similar quantities is going to be taken from two different locations. Are you able to follow this? You must be aware about the differential protection, I hope. Suppose this is the apparatus you want to protect with the differential protection scheme. So what you will do? Suppose as a power system engineer, I want to take the sample of the current. What I will do? I will use two current transformers. Two current transformer I am going to use like this. And what I will do? I will put a relay operating coil like this. So what will happen? Suppose I1 current is following here and the same I1 current is following here. So because of the current transformer, this is CT1, because of some turns ratio, some transformation ratio, this current will be coming something like this, a small I1, and for this current transformer 2, some current must be coming like this, I2 like this. You will be getting a current like this I1, and you will be getting a current like this I1. So the current which is passing through the relay operating coil is going to be I1 minus I2 is equal to 0. So there is zero current passing through the relay operating coil. So there is no way that the relay can operate and send a trip signal to the circuit breaker. And that should be the case because it is a healthy system. There is no fault. Now let us try to understand a case when the fault is going to be present in the system. Now suppose because of any reason some fault is going to be occurring here in between these two current transformers, and such type of fault we are calling as, you can say, through fault. Such type of fault we are calling as through fault, or you can say inside the system which is being protected. If you are getting the fault, then this relay is going to operate. So what will happen? All this I1 current is going to be flowing through the fault, and the current which is coming here, this current will be 0. When this current is 0, I2 is also going to be 0. When I2 is 0, what will happen? This current I1 is going to flow through the ROC. What is ROC? Relay operating coil. When the current is present in the relay operating coil, and if this current I1 is more than the pickup current, what is pickup current? Pickup current is the minimum current above which the relay operates and sends a trip signal to the circuit breaker. So if this I1 current is going to be more than the pickup current, this relay is going to be operating, and the relay operating means the contacts of the circuit breaker will be open, and the system, this apparatus or the equipment is going to be protected against this fault. This is how this differential protection scheme is going to be working. In this question, he is giving you all the currents in different segments, and he is asking you what is going to be the current through the operating coil. Now this question is going to be extremely easy. It is simply going to be, how much? Can you tell me? What is the current? What is the current in this CT? Can you tell me? This current is going to be 220. Now you tell me why you are using the current transformer, why you are not directly taking the sample of the current. Please try to understand. One thing is, directly you cannot take the sample. Also, when we are using the current transformer, our intention is we don't want to directly deal with the fault current, we want to deal with a lesser current. It means the current which is going to be reflected in the secondary of the CT, the primary of the CT is the line itself. This is going to be a lesser value. In the CT secondary, the current is going to be a lesser value. How it can be a lesser value? If you multiply with this CT ratio like this, 5/400. Can you solve this? Can you solve this? What is the current you are getting here? It is 250, and it is also going to be a lesser value than the line current. So you have to multiply with the CT ratio something like this, 5/400. Just solve these two values. Can you just tell me what is the value you are getting here? And see, I am calling this as I1 and this as I2, and this current will be like I1 and this current will be I2, and the current here is going to be coming as I2 minus I1. Just tell me what is the value you are getting. Shivajit is saying that this type of system we can install only for a small system, not for big, because there it is not to be. No. See, this differential protection scheme is also used for transmission lines also. Let me tell you, they are used for generator protection, okay, alternator winding protection. They are used for the transmission line protection also. You must be listening the pilot fire protection scheme. That is where we are using it. There are some additional equipments used because it is going to be a very long distance, but it is used for transmission lines also. Okay, you can read it in some of the standard books. You can read it. So as for my memory, I think you must be getting C as the correct option, 0.375. Is it clear? Yes, Prakhar. Everybody just tell me in the comment section, are you able to follow this? Yes, option C is going to be the correct one, 0.375. Let us see the next question. The next question talks about find the plug setting multiplier, and he is giving you two cases. Now please try to understand what is the concept of plug setting multiplier. What is the concept of plug setting multiplier? You must be reading a lot of books, lot of content, lot of material, but let me give you one of the most simple and practical understanding of plug setting multiplier. Suppose in this class there are 100 students and I want to know who is the most brilliant student in my class. So what I will do? I will take a test, yes or no? And all the 100 candidates, whatever marks, whatever score they are getting, I will compare it with a reference value, yes or no? The same thing we are doing with the plug setting multiplier. Plug setting multiplier is a parameter, is a criteria which tells us that what is the severity of the fault, how dangerous the fault is, this information is given by plug setting multiplier. So we can say it gives the severity of the fault. It gives the severity of the fault. So how you are going to find this value, this parameter? See, what is my reference value when I talk about faults? When I talk about the relay operation, my reference value is the pickup value. So how much value of the current is more than that of the pickup value, more and more dangerous fault it is going to be? Yes or no? Suppose if the pickup current is 5 ampere. So if you are getting a fault current of 5.1 ampere, then it is going to be a fault. But if you are getting a fault current of 20-50 ampere and the pickup current is 5 ampere, it means the fault severity is very, very high. So you can just write it as, this is going to be the fault current in CT secondary. If you know the relay operation, circuit breaker operation, then you will be able to understand why I am writing it CT secondary. Because we are taking the sample of the current from the line, and the line itself work as the primary of the current transformer. So whatever current sample we are taking, that is going in the secondary of the CT. Now this current we are comparing with the reference, that is the pickup value. Actually this is the basic expression or the formula for the plug setting multiplier. But the problem is, when he will give you the question in the examination, he will not directly give you this current value. He will actually give you the value of the fault current in the primary, that is the fault current in the line. Now you can very well understand that if I have to write, listen very carefully, if I have to write the fault current in CT primary here, and what you actually want the fault current in the CT secondary, what is going to be a bigger value? Fault current in the CT secondary or fault current in the CT primary? Definitely fault current in CT primary is going to be a larger value. We are taking the sample of the current from there. So the CT secondary value of the fault current is going to be lesser value. What you have done, you have written a higher value. It should be a lower value. How you can transform it into a lower value? Just use the CT ratio like this. Just divide it by the CT ratio, but this CT ratio must be more than 1. You define the CT ratio of the current transformer so that it is more than 1. So this higher value, if you divide by something which is more than 1, definitely you will be getting a lesser value, and that is nothing but the fault current in the CT secondary. How you are writing the pickup value? Now please try to understand. You have another formula, that is the relay setting. Now what is the actual understanding of relay setting? Please try to understand. Suppose you design a relay and you say, sir, this relay is going to operate whenever the current is more than 5 amperes. That is, the pickup value of the current is 5 ampere. I will say, okay, great job done. But in my system, in my power system, there may be 100 different cases where the pickup current has to be different. So it is not always that all the time I need only 5 ampere as the pickup current. So do I have any flexibility in deciding the pickup value of the current of the relay? Yes. And that flexibility is a relay setting. What you are doing, number of turns of the relay operating coil you are changing. So you will be getting it as pickup current divided by rated ROC current. Rated ROC current. It means this pickup current is going to be decided by the rated ROC current is fixed, but this is going to be decided by the relay setting. What is relay setting? Just change the number of turns of the relay operating coil and you will be able to have different values of the pickup value for the relay. So what you can write in terms of the pickup value? Relay setting multiplied by the rated ROC current. So this formula now goes as relay setting multiplied by rated ROC current. So this is going to be your final expression for the plug setting multiplier. Is it clear for everybody? Just tell me in the comment section. Now very easy it is to find the solution. You have to find the plug setting multiplier. Fault current in the CT primary fault current 2000 amperes. 2000 amperes. It should be a smaller value divided by the CT ratio. CT ratio, if you solve it, it is going to be 80. Yes or no? More than 1 you have to write. Just write 80 here. What is the relay setting? 125. So this is going to be 1.25. What is the rated ROC current? Rated ROC current is secondary CT current, rated current, that is 5. So it is going to be 5. If you solve this, you will get as 4. For the second case, rest other things are going to be same. The only thing is the primary fault current is reduced from 2000 to 200. So this will become 200. This is 80. This is 1.25. This is 5. So you will be getting 0.54. Is it clear for everybody? Just tell me in the comment section. Now listen very carefully. As I told you that the plug setting multiplier gives you very important information about the severity of the fault. Now understand, this plug setting multiplier can give you some more information. If plug setting multiplier is more than 1, what does it mean? It means the relay must operate. The relay must operate. When the plug setting multiplier is equal to 1, it means the relay is on the verge of operation. Verge of operation means about to operate. Not yet operated, but about to operate. What happens when plug setting multiplier is less than 1? It means the relay should not operate. Should not operate. Is it clear, everybody? So this is what we can do till now, because we are running short of time. There are some more questions to be solved. Those questions I will be giving you in the form of the PDF or the PPT. You can join my personal Telegram channel, which is available on BYJU'S Exam Prep. This Telegram channel you can join after the session, and I will be sharing the PPT or the PDF. You can solve or try these questions. You can discuss with me. Any other help also if you require in terms of your examination or otherwise, if I am in that capacity, definitely I will help you out. So you can join this Telegram channel. The Telegram channel name is Electrical by Ashutosh Saxena. That is my name. Okay, it is available on BYJU'S Exam Prep. So thank you so much, friends, for joining me live in the discussion. This is all we are able to discuss today because of the limited time. Some questions I am giving you as part of your homework. Just get this PPT or the PDF remaining questions. You can solve them and discuss whenever you want to. Thank you so much. Take care of yourself. All the best. Thank you so much. Thank you everyone. Shubhajit especially.